All right, let's take a look at today's lesson. We're going to be working with circles and ellipses today. And so let's look at our equations. So this is the definition of a circle, right? It's the set of all points equidistant from the center. And this is our formula. This is a formula that would be given to you. Like I was explaining earlier, these main formulas right here you will get. You just won't get the supplementary, the additional formulas. So H and K is the center. Okay, and here's an example of a circle that's been graphed with the center is at H and K, and then we have a particular point that's on the curve. All right, so let's note the formula also. Notice there are no numbers in front of here, right? There are no numbers in front of here. There's nothing. It needs to be a 1. Okay? So let's practice with the circle. So find the center and radius of the circle. We get to do our completing the square business. So I'm going to take you back and remind you of this work that we did at the beginning of the last lesson. Remember this? All right, we wrote down all of these instructions. We talked about grouping like variables together, moving the constant to the other side. This is the whole process. We're going to do this process over and over again. We're going to do this process where now, I'm not going to write all this over and over again. We talked about that, on how that works, and I wrote that all out, all of the steps. So that's the process that we're going to take when we are putting this in standard form. All right, so I'm going to group together the x's, 2x squared minus 28x, and the y's, and I'm going to move the constant to the other side. If you look at our directions from the last lesson, from the beginning of the last lesson, that's the first thing. Group the x squares and x's, y squares and y's, move the constant. The next step is we're getting ready for completing the square. So I've got to, if the, let's just look at these two. These two, that's going to need completing the square. And we talked about this last time. Why is this needing completing the square? Because we have this extra x, right? We've got an x squared and an x. That means we have to complete the square. This one does not need to complete the square. And why not complete the square? Because there's not an extra y there, right? So we've got two different scenarios going on here. One, the x's I have to complete the square on, the y's I do not. All right, so let's work with the x's, working on completing the square. Recall, this number, this leading coefficient has to be a 1. It can't be anything else, so I have to factor the 2 out just from the x's. Okay, I'm not factoring the 2 out from the whole equation, just from the x's. Okay, so now we go through our completing the square process. We take half of b. Remember, b is 14, so half of 14 is 7. We square 7, we get 49. And I didn't really just add 49. I actually added 2 times 49 to this side. So that's what I have to add to the other side. So 2 times 49 is what, 98. Okay, so we're going through the completing the square business. Once we get the square completed, we clean it up, we factor. So 2 times x minus 7 squared plus 2y squared equals Let's see, negative 80 plus 98 is 18. All right, comparing it to where we're going, as we look at this formula right here, okay, it doesn't look like that. I've got those 2's hanging out there. That's not okay. That has to be a 1. So I need to get rid of the 2's. So the way I'm going to accomplish that is dividing this whole thing by 1/2. That's going to accomplish my getting rid of the 2's. So that leaves me x minus 7 squared plus y squared equals 9. Now we are in proper form. Since we're in proper form, we can read, they wanted us to find the center and the radius. The center and the radius. The center is going to be, this number, right? And this is a 0. So the center is going to be at 7, 0. The radius, remember the formula, that is r squared. 9 is r squared. That's what it is. If you look at this formula over here, you can see that that number represents r squared. So what do I have to do to find the radius? Well, I'm going to have to square root that number, right? Because I need r, not r squared. So my radius is 3. So that's one of the benefits of writing your equations in standard form, is because you can read information out of it. It's quite handy. Okay, and that is working with the circle. I want to talk about ellipses, and then after I talk about ellipses, I want to compare and contrast a circle with an ellipse. Okay, I want to talk about those two, but I want to talk about ellipses first. So, ellipses, we have two scenarios. We've got a horizontal ellipse and a vertical ellipse. So, what is the deal here? So, let's look at this inequality right here. For ellipses, A is the larger number, period. A is the larger number. So here's A. That's going to be the bigger number. Why is this a horizontal ellipse? Because the bigger number is with the x's. The bigger number is with the x's. That's why it's horizontal. On a vertical ellipse, A again is the bigger number. The bigger number now is with the y's. That's why it's a vertical ellipse, because the biggest number determines what kind of ellipse it's going to be. So this little formula right here, this little formula to help find the focus, this you're going to have to memorize. Okay, so put an asterisk right here. This is memorize. You're going to be given the big gigantic formulas, but the little ones you need to memorize. And so what is this? What is this formula? This formula relates these letters together, A, B, and C. So let's get specific about what each of these letters is. So this is my center. The distance between my center and the longest side, my vertex right here, that is A. That distance is A, the distance between the center and the main vertex. This is called the major axis. That is called the major axis. Why? Because it's the biggest one. It's the one that's A. The distance between the center and the smaller axis, these are called co-vertices. Co-vertices. This distance is B. And the co-vertices are on the minor axis. We're just going through the parts of the ellipse. What are all these, the names of the parts? We're just talking about the names of the parts. So this is the center. Let me write center. The distance between, one more distance we need to talk about. The distance between this is a focus. The distance between the focus and the center is C. That's what the distance is. So we've got our ellipse labeled with all of our distances. A is from the center to a vertex. B is from the center to a co-vertex. And C is from the center to a focus point. This formula right here relates those three variables together. The A and the B and the C. Like if we have two of them, we can find the third by using that formula. That's the benefit of that formula. Is it allows us to find other parts of the ellipse that we don't have. Eccentricity is a measurement that's created by this formula. Now I am not going to require you to memorize eccentricity or the formula. In other years, sure, but this year, no, we're not going to memorize that. I just would like to talk about it. It's a number that determines the shape of the ellipse when we're dealing with ellipses. Eccentricity is C over A. C is the distance between, it's the purple one, A is the blue one. We just talked about those. And the eccentricity value is going to be between 0 and 1. The smaller the value, the more the ellipse looks like a circle. Like the closer it is to 0, the fatter the ellipse is going to be. The closer it is to 1, the more narrow the ellipse is going to be. And this is just FYI. We aren't really going to be using. There's a lot of ways you could use eccentricity, like to write equations and stuff, but we're not going to do this year. I just need you to understand that it's a thing, and we're just going to choose not to use it this year. Okay? So that's all of the parts of our ellipses. So let's go over here and let's write an equation of an ellipse. And then we'll graph one on the other page. Just like when we were working with parabolas, I highly recommend that you draw this out. You should really draw this out. Just draw you a little graph and plot the points and label them. So my center is at 2, -3. So I'm going to put this here and I'm going to put C for center. That's my center. One focus is at 3, -3. So that's a focus. And one vertex is at 5, -3. So that's a vertex. And it wants us to write the equation. Okay, well, first up, we can see that our center and vertex are horizontal. They're spaced horizontally from each other. This is going to be a horizontal ellipse. That's one piece of information, because the vertex is on the major axis, which determines what kind of ellipse it is. So the next thing that I want to know is I want to determine distances. So if I look at this right here, okay, the distance between the center and the vertex, I would just count it, 1, 2, 3. So A is 3. I'm getting that off of my graph. A is 3. What other clue do we have? Well, we also know that we also have another distance. We've got this one right here. That is the distance between the center and the focus. That's C, and C is 1. Okay. My center is HK. HK is my center. All right. So let's write down the formula for a horizontal ellipse. I'm just going to write it right up here. So it's x minus h squared over a squared plus. Of course, as I was saying, you don't have to memorize these. We're going to give you these formulas. Okay, so let's fill in the blanks to our formula. We're going to fill in the blanks. So I already know h is 2, x minus 2 squared. Okay, I know h is 2. I know k is negative 3. Okay, got that part. If you have the center, you can write like half the equation is done. It's right there. I read A off of my graph. See, A is 3. So I should have 3 squared right here. And I know it goes under the x because this is a horizontal ellipse. Now, I don't know what B is, but I have clues over here. I have clues that will allow me to find B. There's some clues over here. I know what A is, and I know what C is. And now this is a formula you have to memorize. It's A squared minus B squared equals C squared. This is one from our memory. It really shouldn't be that bad. It's almost exactly like Pythagorean. Right? The only difference is it's a minus instead of a plus. So I'm going to use that formula to determine what B squared is. All right, so I've got A, which is 3, A squared minus B squared equals, and C is 1. Okay, so now my job is simply solve for B squared. So I'm going to move the B squared to the right. And that's what, 9 minus 1. So B squared is 8. Okay. B squared is 8. So to finish just to write this out in perfect form, I have x minus 2 squared over 9 plus y plus 3 squared over 8 equals 1. All right, and that is writing an ellipse equation from information given. How are we doing? Okay. Our last example is graphing. Okay. Come back. Don't you love it when it just decides, oh, I don't want to do that. Okay. So we've got to fix our equation first. So here we go. We're going to group the x's together. So x squared minus 2x. Group the y's together. Plus 9y squared minus 54y. Move the constant to the other side. I'm going to have to complete the square twice. I'm going to have to complete the square here and here. Why? Because I have an extra x and an extra y. All right. So I've got x squared minus 2x. Half of 2 is 1. 1 squared is 1. Plus 1. Plus 1. Okay. Are the y's ready to complete the square 2 yet? Nope. I got to factor a 9 out. So let's pull a 9 out of just the y's. So that leaves me y squared minus, what is that, 6y. Okay. So I half b. Half of 6 is 3. 3 squared is 9. So I add 9. But did I really just add 9 to the left side? No, I added 81. I have to counter it with what I truly added, which was 81. Okay, now we clean up by factoring. I have x minus 1 squared plus 9 times y minus 3 squared equals, let's see, negative 73 plus 1 plus 81 is 9. Okay, so let me get us all caught up here, and then I want to compare this to a circle. This is where I want to stop and compare this to a circle. I want to show you why they are different. And how will you know if it's an ellipse or a circle? That is a question students have difficulty with sometimes. How do you know whether it's an ellipse or a circle? Is everybody where I am right now? Okay, so I would like to go up here and let's look at this right here. The one that I underlined, see that right there? Okay, I want you to notice that 2 is in front of the x's and 2 is in front of the y's. That's how I know it's a circle, because it's the same number in front of both. It's the same number in front of both. It's a circle. So if it's the same number in front of both, I just divide by that number, I'm done, or multiply by 1 over that number. Okay, that's a circle. Here, I've got a 1 right there, and I've got a 9 right there. That is not a circle. Those numbers are not the same. Since those numbers are not the same, and that's the key up here, ladies. So if I go up here, to get this in proper form, it's the 2 I need to get rid of, right? The number that's the same for a circle. That's how I get the circle in proper form, is getting rid of those 2's by multiplying through by 1/2. When we have the number not being the same, that's not what we do. Instead, what we do is we turn this last number to a 1. We turn it to a 1. So instead, what I'm going to do is I'm going to divide everything by 9, or multiply everything by 1/9, however you want to think about it. I'm dividing everything by 9. And so that leaves me x minus 1 squared over 9 plus 9 over 9 is 1. So that leaves me y minus 3 squared. And if you wanted to write it over 1, you could. You don't have to. Equals 1. That is the standard form of an ellipse. You have to equal 1 in standard form of ellipses. All right. So the major axis is the one that has the bigger number under it. In this case, 9 is biggest, so it's a horizontal major axis. Reading these information off of our graph, A is going to be the square root of 9, which is 3, and B is going to be the square root of 1, which is 1. To find C, I simply use my little formula, which is a squared minus b squared equals c squared. So I've got 3 squared minus 1 squared equals c squared. So, and let me move this so I have room to write my vertices. I'm just moving it up here. So that means c squared is 8. So C is plus or minus 2 root 2. Okay, the center we can read right off of the equation. The center is 1, 3. That's the center. So to get all the other things, I'm going to graph as I go, just like we did with parabolas. Just graph as we go. The center is at 1, 3. There's my center. Okay, it's a horizontal ellipse. A is 3. That means that I go 3 spaces to the right of my center and 3 spaces to the left. Okay, that's a vertex, and that's my center. So let's write our vertices down. So our vertex is 1, 2, 3, 4, 3, and negative, let's see, what is that? Negative 2, 3. Those are my vertices. Okay, so how did I do that? I went the distance A. Okay, now I'm going to erase these letters. Are we all right with that? The C and all that. I'm going to erase that business. Okay. Co-vertices. That's my distance for B. I go above B, 1, and down. These are my co-vertices. Co-vertices. So the points for my co-vertices are 1, let's see, is that 2, 3, 1, 4, and 1, 2. And so let's erase my little letters. So in graphing, I'm just going to go ahead and graph my ellipse. We just need to connect all the vertices and co-vertices together. Okay, there's my ellipse. We need to work on the focus points, but before I do that, I want to do domain and range. Domain, we know, is the smallest x to the biggest x. So the smallest x, and these are included, the smallest x is negative 2, and the biggest x is 4. Range, we know, is from the smallest y to the biggest y. So there's the smallest y, and there's the biggest y. Okay, so the smallest y is 2, and the biggest y is 4. Now, the foci, the focus points, are weird, right? As we look, let's just look at this. Well, hold on, let me hold there for a minute. Is everybody good so far? We all caught up? We've got our domain and range written down. All right, so let's look at this picture right here. C is the distance from the center to the focus. That's C, right? That's a distance. And so here, C is 2 root 2, or square root of 8. So I'm going to go, let's see, the square root of 8 is a little bit smaller than the square root of 9, so it's a little bit smaller than 3. So I'm going to go 1, 2, I'm going to go, here's a focus point about right there. And then, you know, right about here, right? It's a little bit smaller than 3. So my focus points are always on the major axis. Always on the major axis. And this distance is C. Right? That distance is C. So when I write the points, my focus points, it's a little weird. Some students get a little bit weirded out by this. Okay. Oh, gosh. Come back, little thing. Oh, my word. Okay. Just really not being very helpful today. That's okay. So how do we write our focus points? So what do? Our center, we always write off the center. So I'm going to write out the center. The center is 1, 3. Okay, the center is 1, 3. Our focus points are always written from the center. And so what are we doing? We're going, for our focus points, we're doing 1 minus 2 root 2, 3, right? So that gives me this one right here. We're starting at the center, which is 1. We take away 2 root 2. That gets us to the x coordinate, and the y coordinate is 3. The other focus is 1, and now we're going the other way, plus 2 root 2, 3. I know that usually kind of freaks people out. I was like, what? What are you doing? To get the focus, we have to measure from the center. And yes, I know that's some weird decimal number. We really don't care. We just want it to be an exact form. Exact form is 1 minus 2 root 2, 3, and 1 plus 2 root 2, 3. And those are our 2 focus points, which I'm going to rewrite over here. So we've got 1 plus 2 root 2, 3. And we've got 1 minus 2 root 2, 3. Now some students want to write those together as 1 plus or minus 2 root 2, comma 3. You certainly can do that if you would desire. Okay.